Article 800 of the National Electrical Code addresses feeders. Specifically, 800.102 discusses feeders, noting that they shall originate in an approved service equipment or transformer secondary within a mobile home distribution panel board. Overhead feeders must be installed in accordance with the requirements of Article 320 and installed in, on, or above buildings or other structures in accordance with Article 230, Part 3. Service entrance cables shall be permitted as overhead feeders, and such cables shall be installed in accordance with Article 338. An informational note directs readers to Article 551 for additional requirements for manufactured home park feeders. Article 230 detail services. 230.1 describes the scope of Article 230, stating that it covers requirements for installation and use of services, feeders, and branch circuit. It also provides guidance on the selection, installation, and use of equipment for the purpose of delivering electrical energy from service points to outlets or loads, such as appliances, lighting, and motors. 230.2 details general requirements. 230.2 selection and installation states that services, feeders, and branch circuits shall be selected and installed in accordance with the requirements of this code. 230.2b listing requires states that electrical equipment shall be listed and installed in accordance with the listing requirements and shall be used only in a manner and for an application for which it is listed unless otherwise specifically permitted by this code. 230.9 covers wire types and ratings. 230.9 states that insulated conductors shall be of the type approved for the purpose and shall be used at temperatures not exceeding those for which the conductors are approved. Conductors used for AC or DC general purpose wiring shall be suitable for use in wet or dry locations, as required by the installation conditions. The following conclusions can be drawn. Overhead feeders must be installed in accordance with Article 320 of the National Electrical Code. Article 320 does not explicitly require sunlight-resistant marking on wire for overhead feeders. If an inspector is requesting the installation of sunlight-resistant marking on the wire, and that requirement is not found in the National Electrical Code, that can be addressed. Wire manufacturers have stated that sunlight-resistant marking may not be available on 10-gauge THHN wire. When dealing with an inspector who is requesting something not explicitly stated in the National Electrical Code, the following information should be provided. The National Electrical Code does not require sunlight-resistant marking on wire for overhead feeders. Also, that wire manufacturers have stated that sunlight-resistant marking is not available on 10-gauge THHN wire. If the inspector continues to insist that sunlight-resistant marking is required, the authority having jurisdiction, or OJ, may need to be contacted for clarification. It's important to understand the specific requirements outlined in the National Electrical Code when installing overhead feeders. While some inspectors may have specific local requirements, it's crucial to ensure that those requirements align with the NEC or have a valid basis. Sunlight resistance is a critical factor in outdoor wiring installations. Sunlight can degrade insulation over time, leading to potential safety hazards. Understanding the types of wires that are suitable for outdoor use is essential. THHN wire is a common type of building wire used in conduit or other raceways. While it's suitable for dry and damp locations, it's not inherently sunlight resistant unless marked as such. When installing overhead feeders, you need to ensure that the wire is rated for outdoor use. This often means using a wire with a sunlight-resistant jacket or using a conduit to protect the wire from direct sunlight. Article 320 of the NEC covers the requirements for armored cable. While it doesn't specifically address sunlight resistance, it does provide guidelines for the installation of cables in various environments. If you're using armored cable for overhead feeders, you need to ensure that it's suitable for outdoor use and protected from physical damage. Article 230 of the NEC covers services. It provides requirements for the installation of service conductors, including overhead service drops. While it doesn't specifically address sunlight resistance for feeders, it does emphasize the importance of using approved wiring methods and equipment. The authority having jurisdiction, or OJ, is the local authority responsible for enforcing the NEC. If you encounter a situation where the inspector's requirements differ from the NEC, you may need to contact the AHA for clarification. They can provide guidance and help resolve any discrepancies. When selecting wire for overhead feeders, you need to consider the ampacity requirements. The ampacity of a wire is the maximum amount of current it can safely carry. The ampacity of a wire depends on its size, insulation type, and installation conditions. You can find ampacity tables in the NEC. When installing overhead feeders, you need to ensure that the wire is properly supported. The NEC provides guidelines for the spacing of supports for overhead conductors. Proper support prevents the wire from sagging and potentially contacting other objects. Grounding is an essential part of electrical safety. When installing overhead feeders, you need to ensure that the system is properly grounded. This helps to protect against electrical shock and equipment damage. The NEC provides detailed requirements for grounding electrical systems. Overcurrent protection is another critical safety feature. When installing overhead feeders, you need to provide overcurrent protection to protect the wire from overloads and short circuits. This is typically done using circuit breakers or fuses. The NEC provides guidelines for selecting the appropriate overcurrent protection device. Voltage drop is a concern in long wire runs. When installing overhead feeders, you need to calculate the voltage drop to ensure that the voltage at the load is within acceptable limits. The NEC provides guidelines for calculating voltage drop. When working with electricity, safety is paramount. Always disconnect the power before working on electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. The NEC is a complex document. It's essential to have a thorough understanding of the code before attempting any electrical work. Consider taking an electrical code course or consulting with a qualified electrician. Local codes and regulations may vary. Always check with your local building department to ensure that you're complying with all applicable codes and regulations. Documentation is essential. Keep records of all electrical work, including permits, inspections, and materials used. This can be helpful for future maintenance and troubleshooting. When contacting wire manufacturers, be specific about your application. They can provide guidance on selecting the appropriate wire for your needs. They can also provide documentation to support your installation. When discussing the issue with the inspector, remain professional and respectful. Clearly explain your understanding of the NEC and the information you've gathered from wire manufacturers. If the inspector remains unconvinced, politely request clarification on the specific code section they are referencing. If necessary, escalate the issue to the AHA. Be prepared to provide documentation and support your position. Remember that the goal is to ensure a safe and compliant installation. Working collaboratively with the inspector and AHA can help achieve this goal. In summary, when installing overhead feeders, it's essential to understand the NEC requirements, select appropriate materials, and follow safe work practices. If you encounter any discrepancies or have questions, consult with qualified professionals in the AHA. By following these guidelines, you can ensure a safe and compliant installation. Additional considerations may arise based on specific environmental factors. For instance, if the installation is near a coastal area, corrosion-resistant materials may be necessary. Similarly, in areas prone to extreme temperatures, wires with appropriate temperature rating should be selected. Always refer to the NEC for specific requirements based on the environment. Furthermore, ensure that all wiring and equipment are properly labeled. This helps with future identification and maintenance. Labeling should be clear, durable, and compliant with NEC requirements. Regular inspections are crucial for maintaining the safety and reliability of electrical installations. Schedule periodic inspections to identify and address any potential issues. Keep records of all inspections and maintenance activities. Continuous learning is essential in the electrical field. Stay updated on the latest NEC revisions and industry best practices. Attend training courses and workshops to enhance your knowledge and skills. Remember, the NEC is not a substitute for sound engineering judgment. Always apply your knowledge and experience to ensure a safe and reliable installation. If you're unsure about any aspect of the installation, seek guidance from a qualified professional. The ultimate goal is to protect people and property from electrical hazards. Prioritize safety in all aspects of your work. By adhering to the NEC and following best practices, you can contribute to a safer electrical environment. Also remember to take into account the expansion and contraction of wires due to temperature changes, especially in overhead installations. Use appropriate methods to accommodate these changes and prevent stress on the conductors and connections. Ensure that all connections are properly tightened and protected from corrosion. Use appropriate connectors and terminals that are listed for the specific wire type and application. Consider using antioxidant compounds to prevent corrosion at connections. When running overhead feeders near trees, maintain adequate clearance to prevent contact between the wires and tree branches. Tree branches can damage the insulation and create a safety hazard. Consult with local utility companies for guidance on tree trimming near power lines. Be aware of potential hazards from wildlife. Animals can damage wires and equipment, leading to power outages and safety risks. Take precautions to protect the installation from wildlife damage. Consider using deterrents or barriers to keep animals away. Follow all applicable safety regulations and guidelines when working near energized equipment. Maintain a safe distance from power lines and other electrical hazards. Use insulated tools and equipment to minimize the risk of electrical shock. Before digging near underground utilities, always call 811 to have the utilities located and marked. This prevents damage to underground cables and pipes, which can cause serious injuries and property damage. When installing overhead feeders across roadways or other public areas, obtain the necessary permits and approvals from the local authorities. Comply with all applicable regulations and safety requirements. Ensure that the installation does not obstruct traffic or create a safety hazard. Consider using underground feeders as an alternative to overhead feeders. Underground feeders are less susceptible to weather damage and can improve the aesthetics of the area. However, underground installations require careful planning and execution to ensure proper drainage and protection from physical damage. Document all changes and modifications to the electrical system. Keep accurate records of all wiring diagrams, equipment specifications, and inspection reports. This information is essential for future maintenance and troubleshooting. When decommissioning or removing electrical equipment, follow proper procedures to ensure that it is done safely and without causing any environmental damage. Dispose of all waste materials in accordance with local regulations. Stay informed about new technologies and advancements in the electrical industry. Attend trade shows and conferences to learn about the latest products and techniques. Embrace innovation and strive to improve the safety and efficiency of electrical installations. Remember that the electrical code is constantly evolving. Stay updated on the latest revisions and interpretations to ensure that your installations are compliant and safe. By continuously learning and improving your skills, you can contribute to a safer and more reliable electrical system for everyone.